On this section of Chapter 3, we're covering inequalities but in two variables. So let's do some basic problems that you guys did back in algebra just to kind of get the ball rolling. Number 1. Let's graph y is greater than or equal to 2x minus 1. Again, the difference between this and the past two sections is that now you have two variables, y and x, so we have to graph this in a coordinate plane. So first and foremost, we can graph this line. It has a y-intercept negative 1, up 2, over 1. And there you go. So a couple quick things. One, obviously we have to graph the line. 2, we have to ask yourself, is it dotted or solid? In this problem it was solid because it was equal to. And 3, we have to shade. So when you shade, you can just pick a test point. I see 0, 0 is not on the line, so I can plug in 0. 0, it must be greater than or equal to 0 minus 1. That is true. Therefore, I'm shading above the curve. So let's do another one. Let's do a real simple one, but important. On this problem, I have to tell you that it was a two-variable problem. Otherwise, you could interpret this as a problem from last section. If you graph this in a coordinate plane, you have to realize that x equals 1 is a vertical line at 1, and then the shade to the right. Again, it's solid because it's equal to. And there, that's it. Let's do another one. How about y is equal to 4, is less than 4 minus x squared. You should know this graph off the top of your head. It is simply the x squared curve, up 4 and flip down. But we should find the x-intercepts. If you factor this, you get 2 minus x and 2 plus x. And you can see there, therefore this is at 2 and negative 2. Now, I would advise you not to use pen because of what just happened. I graphed this rather quickly. I mean, all naturally draw everything connected, but I can't erase because this line should be dotted. So I'm just going to make that note there that this is dotted. If it happens on a test or quiz, I will accept that. But again, pencil would be optimal in this situation. So dotted. Now we've got to check our shading. Again, 0, 0 is an optimal point to plug in. So when I plug this in, I get 0 is less than 4. That's true. Therefore, I'm shading inside. Let's do one or two more. So number 4. Let's do y is less than or equal to x cubed plus 2x squared. So a little bit harder. Again, we solve it, we just have to graph it. So when we graph this, we can pull out the x squared, and we're left with x plus 2. Therefore, x is equal to 0 and negative 2 in our sign analysis. On our sign analysis, we can see that 0 has a double root. We can plug in something like 5. Again, this is always positive because it's being squared. So this is positive. If we plug in negative 1, we get positive. If we plug in negative 3, though, we get negative. So our graph will be negative here. I'm going to check it's a solid line, so I can't connect the dots here. And with a double rooted 0, then up. The unfortunate thing is we can't plug in 0, 0 because that point is on the actual curve. So I'm going to plug in this point here. So I'm going to plug in negative 1, 0. That's an easy point to plug in. 0 is less than or equal to negative 1 plus 2. So 0 less than or equal to 1. Yes, it is. So the shading is all beneath the curve. The last one we can do is y is less than x to the 4th minus 5x squared plus 4. Again, this is just a factoring problem. I'm just trying to play with the factoring skills from last chapter. X squared minus 4 times x squared minus 1. And you can keep going to x plus 2 times x minus 2, x plus 1 to x minus 1. And this graph should be very familiar to you. It's a quartic function from last chapter. If you do the sign analysis, they're all linear roots. So it's going to be an absolute sign change on every single one of them. It's going to start off with positive because it's a W, minus, plus, minus, plus. So when we graph this, I'll graph it over here. You have negative 1, negative 2, 1, 2. And again, we can see the W shape. Positive, come up. And again, I did it again. It's supposed to be dotted. So I'm going to make a note here that it's dotted. And now let's check our shading. We can plug in 0, 0. If we do that, we get 0 is less than 0 minus 0 plus 4. And it's true. I think it was true every time, every problem. Therefore, it's shading all down here and outside here. And that wraps it up. So in class, we will cover some more difficult ones as well as a system of polynomial inequalities, which is obviously a little bit more interesting. Enjoy the rest of your night.